So here we need to find out the distance between 2 points, point A and point B. Now the coordinates of the point A and B are given. So A has the coordinate A sine alpha, comma, negative B cosine alpha, and B has the coordinate negative A cosine alpha and B sine alpha. So let's try to find out the distance between the 2 points. For this, we'll have to use the distance formula. So let's first specify the distance formula. Here we have 2 points, point A and point B, which is joined by a straight line. Now A has the coordinate points x1, y1, and B has the coordinate points x2, y2. Now the distance formula states that the distance, that means the straight line, distance of the straight line joining point A and B, is given by square root of, underneath the square root, first we will take the square of the difference of the x coordinate and add it to the square of the difference of the y coordinate. Fine. So here we will suppose that our point A, which is A sine alpha, comma, negative B cosine alpha. So let's say this corresponds to the point A with coordinate x1, y1. So this means that x1 is going to have a value A sine alpha, and y1 is going to have a value negative B cosine alpha. Then we go to the next point B. So B has the coordinate point negative A cosine alpha, comma, B sine alpha. So we're going to make it equivalent to b x2, y2, such that we get the value of x2 as negative a cosine alpha and y2 value. So that corresponds to b sine alpha. Fine. Now what we'll do, we'll first begin by computing the value x2 minus x1. So here x2, that's negative a cosine alpha. And from it, we're going to subtract x1. So x1 is negative a sine alpha. Fine. So we'll take negative a as the common factor. So we have negative a multiplied to cosine alpha plus sine alpha. So let's keep it as it is. Now next, what we'll do, we'll try to find out the difference of the y coordinate. So we'll do y2 minus y1. So here y2 has the value b sine alpha. So we have b sine alpha. And from it, we have to subtract y1, which is negative b cosine alpha. So since we have negative of a negative number, so this will become positive. We get positive b cosine alpha. Now from both the two terms, if we factor out b, so we have b multiplied to sine alpha times plus cosine alpha. Fine. Now let's try to find out the distance between point A and point B. So AB will be simply given by, so we know that that's square root of, so first we'll have to take the square of the difference of the x coordinate and add it to the square of the difference of the y coordinate. So that means y2 minus y1 whole square. We'll substitute the value here. So we will have square root. So underneath the square root, we have x2 minus x1. We need to square it. So we'll take negative a squared. So that is simply positive squared, a squared multiplied to cosine alpha plus sine alpha whole square. This will be added to the square of the difference of the y coordinate. So that's b times sine alpha plus cosine alpha. So when we square it, we get b squared. Multiplied to it will be sine alpha plus cosine alpha whole squared. Fine. Now what we can do, we can take cosine alpha plus sine alpha whole squared as the common factor. So this will be multiplied to a squared plus b squared. And this entire expression will be underneath the square root. Now this is a perfect square. So when we take its square root, this will be simply the absolute value of cosine alpha plus sine alpha. And square root of a squared plus b squared will be simply square root of a squared plus b squared. So this is the final value. That's the distance between point A and point B. So let's try to compare it with our given options. So here option A, so that's the only one that's matching with the result. So square root of a squared plus b squared multiplied to the absolute value of sine alpha plus cosine alpha. So that's going to be the final result.